Yes, I have the great honor to introduce our guest speaker today, Clemens Neudecker. Clemens has a very well-rounded educational background. He studied philosophy, computer science, and political science at Ludwig Maximilian University of Munich. And for more than 15 years, he has been working in research and development at various digital libraries, including the Bavarian State Library and the National Library of the Netherlands. Clemens is currently a researcher and a project coordinator at the Berlin State Library. He is also a member of the Council at Europeana, which is the European Union's digital platform for cultural heritage. His main interests lie in data enrichment, including, for example, OCR or language processing (NLP), artificial intelligence, machine learning, digital humanities, and he's very well known in the fields such as image processing, document layout parsing, and so on and so forth. So without further ado, I will give the floor to our guest speaker, Clemens.
Yeah, thank you very much for the kind words of introduction. Let me just share my presentation, which I hope everyone can see now. So yeah, thank you very much for having me, for providing the opportunity to present our work in this seminar. Also from me, welcome everyone, bonjour à tous, welcome iedereen. As been said, the talk will be done in English, but yeah, feel free to put your questions in any language. So I will be speaking today about what I call new tools for old documents. So some tools specifically focusing on layout analysis of document images that were digitized, historical documents, with the main purpose of running OCR, that is text recognition, in order to retrieve the textual content and continue analyzing and working with that. We're using here a combination of deep learning and heuristics, and this is joint work with my team, as you see the other team members also being listed here. So like has already been said, currently I'm employed as a research advisor, research coordinator at the Berlin State Library in Berlin. It's one of the largest research libraries in Germany, and it's quite an interesting setup since we form one part of a bigger legal entity, the Prussian Cultural Heritage Foundation, which also has a number of world-renowned museums, archives, and the State Library located in Berlin. We have an in-house digitization center that we run with 4 shifts currently, since 2007, producing on average about 2 million pages of digitized documents per day, which has amounted to around about 20 million pages that we currently offer through our digital library. And I'm always happy to say that we strive for a very open license. So most of the images and also the texts where they are available will be publicly domain licensed, and you can download them and retrieve them via APIs and use them for your study. The work that I'm presenting today is done in the frame of a funded project, which is called Curator. Curator is a platform for intelligent content solutions. It's funded by the German Ministry of Education and Research. And it's an interesting combination of both research organizations, but also small and medium enterprises. We also have Wikimedia and Wikidata as partners. And together we try to work on this platform for curating digital content in various application domains. Within this project, the library that I work for is mainly responsible for what is the sub-project 10, where we try to use artificial intelligence technologies or machine learning to better improve access to our digitized content. And we basically strive for 2 main goals here. First of all, we want to improve the quality of the output of digitization, and that specifically with a view, as I said, on the quality of the recognized text. But secondly, we're also working in some other areas with regards to the creation of those texts, for example, with natural language processing technologies, in order to curate those texts automatically or support the experts in the curation. Like with our data, all the tools that we develop in the project are available as open source. You can find them on our GitHub. We also published a number of data sets openly that you can find on Zenodo. And since most of the work here relies on machine learning, we provide also a number of trained models that you can get via that URL. So here I have compiled you some of the examples that we are facing in terms of challenges when we deal with historical document digitization. So we see here we have a huge variety of appearances. We have scans that have been done throughout different times with different qualities, sometimes just black and white from microfilm, for example. We have historical fonts. We have a mix of, especially in the German-speaking countries, the broken letter fonts, Fraktur fonts, with the Roman Latin fonts. Sometimes we have, as you see on the right, handwritten annotations. We have stamps. And we also have newspapers which have very complicated layouts. So these are all challenges when you want to get the text recognized from these images in order to work with the content, with the material. And this is what I will be focusing mainly on today. Yes, so the first step in order to get the text out of these images is really to do layout analysis as an initial means to derive information about where are regions on the page which contain text and what other elements can be placed on the image that are relevant for further analysis. Something that is also especially worthwhile mentioning here is, since we work with a perspective on text recognition, is that current OCR methods very much rely on good layout analysis, which means in fact that they operate on already pre-segmented text lines. So the text recognition method usually just gets to see the image of an individual text line and then tries to recognize the text from that line, which obviously indicates that you need to get a very good text line image beforehand. So for this purpose, we've been basically using a technology that well, many others have been exploiting successfully for document analysis, that is deep learning. Like I said, we operate with images and we want to return the results in a specialized format called page XML, which then contains basically the information about the coordinates of the individual areas of the page. So the regions which contain text, separators, image content, and text content. We built our model around quite an established model, the ResNet model, in combination with UNet, and we use a method called pixel-wise segmentation, which means that pixels are combined into larger segments and then being labeled according to classification. We started out with a very simple approach based mainly on the also quite successful DH segment project, which was developed at the University of Technology in Lausanne in Switzerland. And you see here in the top row on the left side image in blue indicate the different text regions we were able to detect with this initial version, and the text lines on the right image. And as you can easily see, we're missing in this first iteration some important paragraphs and especially text lines, which led us to think about, and also, sorry, I have to say here, some initial challenges were also here, especially in historical documents, for example, drop capitals. So that those are these large initial capitals, characters that sometimes start a text line, and marginals, which are small notes or basically like footnotes, but they are not located at the bottom of the page, but on the margins. And especially once you deal with multi-column documents, like in this newspaper here, a really tricky bit when you want to work with the results of the text analysis is to actually recognize these different paragraphs in the correct order, so that you have the logical order and sentences of the running text. So in order to improve this performance of our initial iteration, we came about that we have a lot of knowledge about the documents, and we can apply some additional heuristics here to kind of support different machine learning models to get a better understanding of the page and thereby improve the performance and the recognition of the different elements, and especially the reading order. And as you can see here in the bottom line, with this now second iteration of this tool, Inola, which by the way stands for the Eye of God, I believe, in Iranian, since our developer is from Iran. You can see that we were able to significantly improve the performance by those additional heuristics. And I include here the link also for this tool on GitHub. So if you're interested in trying out, feel free to have a go at that. Now, as I said, Inola is built around a number of machine learning models that are used in a combination and in basically what we could call a flow, where we apply some additional heuristics to direct basically the flow of the data and the communication between the individual models. You don't need to understand this kind of flow diagram in detail, but basically we start by doing some very simple analysis, like extracting the print space to cut off some margins which may contain noise from the digitization or from the adjacent page. We do some basic image analysis, like to check the scale and the resolution of the document, so that when the document quality is quite bad, we can actually improve it. And then we start what we have designed here as a two-stage layout detection process, where we start with a very early detection of regions. And then we perform an initial text line segmentation. If necessary, we will do some deskewing of the lines. And then we use that information actually in a second step where we compute the full layout with additional regions, and then in the end also the reading order. And I will walk through these steps more or less one by one with some example images to illustrate those. So like I said, sometimes we are confronted with images that were digitized with a low quality, and this is quite challenging then for the models. So one thing that you can do here quite easily is to train actually an AI model to improve the image quality by basically taking high quality images, scaling them down, reducing the optical resolution, so that we derive with these kinds of pixelated or not very sharp images you can see in the top row. And then basically we can do a training of this model to convert those images back into what was their original higher quality format. And that can then be transferred to images which are only available with a low resolution or low quality to get like really greatly improved images that will return much better analysis results. In some cases, and actually we don't use this very much, but I wanted to mention it as well, since Inola is actually operating with a better performance on grayscale or color images. But in some cases, like you can see here, it can also help to perform an image binarization, which means that all the pixels that are foreground, so printed content, will be converted to black, and all the background will be converted to white, as this can help sometimes filter out some of the noise of the printing from the opposite page, or some stains or damages and defects on the image, as you can see on the right side. So then we really start to do the first classification of the different regions and areas of the page. And you can see here basically on the right, this is the analysis of our current model of this image on the right, where we distinguish between different elements. So obviously there is background. We have the main text. We also have a specific classification of headings. Then also, like I've mentioned, the drop capitals or initials. We also classify images, and I will come back to that a bit later. Very importantly are also the separators here, so the lines that in this case separate the different columns. And also here you can already see in yellow the marginalia. So these are the current types of regions that we are able to detect with our system. And yes, so once this region classification has been done, we proceed to the next step, which is for all these regions that are actually text regions, we try to detect the individual text lines within those. Here we use a very simple approach where we look at the pixel density in the horizontal column. And basically, as you can see in the middle, we can construct a very simple scale by which is has a strong value on the x-axis if there is a lot of density of darker pixels, indicating that here is a text line, whereas we have these kind of valleys where there is a very low density of black pixels, and those are usually the spaces in between the text lines. And using this approach, we can derive, as you can see here on the right, this initial text line detection, which yeah, works quite well in those cases. There are, however, some also really challenging examples, as you can see here. So especially once you look at some other alphabets or even handwritten stuff, or sometimes also differences of the font sizes or text that is written in between the lines. So what we're doing here is that we're actually introduced in the text line segmentation model an additional category or an additional class, which is a small space that is basically white and which is then also detected basically as its own image content or image class in the text line detection. And this allows us to really get a very good polygonal segmentation of these text lines. So you see we have very very tight contours around these text lines, which is much better than, for example, operating with bounding boxes, which in those cases would lead to overlapping of those text lines, and then that would lead to unwanted effects and errors in the subsequent stages. We also have sometimes the challenge of skewed, or in this case, warped text lines. And in order to also here get like a good contour around the shape of these curved text lines, what we do is that we actually cut the image into small vertical slices, and then we straighten those individual slices and detect the text lines within those slices. And then later on, we recombine those slices into the full picture again, and combine the different segments of the lines that were detected on these skewed lines, and compute back the dimensions of these segments back to the original image skewing. And this works also surprisingly well, as you can see here on the right-hand side, to avoid again here the overlapping of those text lines. Another thing that we found in our collections were vertical or rotated text lines. As you can see here on the left-hand side, we have some text that is rotated by 90 degrees. So we found that actually we can deal with this quite easily by doing some augmentation in the model training, which means that we use some images that we just rotate, and we feed those additional images which are rotated into the training. And then we do some additional heuristics again here, because the initial segmentation model is recognizing these vertical lines as separators. But if we indicate to the model that in this case we're looking at text regions, It allows us to actually segment also those vertical lines quite well, even when they occur, as you see here in this case, on the same image where we also have regular horizontal text lines. Now, document layout analysis gets especially difficult once you deal with historical newspapers. At least that is my personal experience, as I've been also working with historical newspapers a lot. And as you can see here, we have in newspapers many of the challenging things that are difficult for layout analysis to detect accurately. Like we have sometimes areas which span over multiple columns. We have here in this case 3 columns. Sometimes there are adverts which combine 2 columns. And we have a mix of different font sizes. We have some graphical elements as well. And so here it becomes especially tricky and challenging to correct all those individual segments and instances as their right classes, and then also to get the text in the correct order. So you can see here, for example, on this image, we detect here the separators again, and those are really important feature for us then in the subsequent steps, and also the headings, which are here indicated in light blue. And this is again done in the initial stage of the first segmentation, and then we make use of this information in the second step. Excuse me. So exactly here we see, so it is very important, especially if you then pass the recognized text lines to the text recognition step as individual lines, that you pass them on to the text recognition in the right order. Otherwise, you may get a highly accurate OCR result for the text, but you will not retain the correct logical order of the text. For example, by merging 2 columns into one region of texts. Say, for example, if you look at the top left paragraph article, if we don't manage to properly segment those individual columns, then we may end up with the text of the first column, the first line of the first column, followed by the first line of the second column, and so forth. And this would completely disturb the reading flow, and thus the result would not be usable for any kind of semantic analysis or text mining. So in that sense, it's really important to get the order of these segments correct. And for this, we use this initial segmentation. And then we look again at the separators, like I said, and the headings. And so these we can then use with some additional heuristics, like, for example, that the individual articles and columns are usually then here divided by those separators. And one article starts with a heading usually. And we can dissect the image into these smaller segments, and we then do actually the column and text line detection on smaller patches of the image rather than the whole image completely, which greatly improves the quality of the column detection and the separation, and thereby allows us to get like a really accurate analysis of the full page. A nice thing that we see here as a secondary effect of the different types of categories of image that we classify on the image is that we also here extract or classify image content. So for example here, this is basically a byproduct of the layout detection. We can find out which areas contain such graphical content, and we can actually find out that there are additional application scenarios for using this information, for example, to find similar images. So this is something that came basically as an added bonus of this document layout analysis. that we were able to find over 600,000 illustrations or images in our scanned printed documents. And we extracted those and trained a specific image classification model based on the popular ImageNet. And we even did a small additional model using the YONO object detection technique, which allows you to select a region of interest by drawing a boundary around a certain particular element of the image that you're interested in. And then we can find actually similar images following a nearest neighbor search from these other 600,000 images that we extracted. And this came basically as a byproduct of the layout analysis. And we have found that this is very much in demand from users who really value this additional option to browse and search the documents other than just keyword search, but through this more explorative graphical similarity search. Now, coming back to the main purpose, really getting text output. So, as I've said initially, OCR, especially for historical documents, is still quite hard. You have to deal with these old and broken fonts, you have to deal with historical spelling, and so forth. But also here, deep learning OCR methods have come available in recent years that were able to really significantly improve the performance of those text recognition algorithms. And something that I generally have to applaud to a lot is the effort to create publicly available data sets of ground truth. So that is the transcription, the 100% correct transcription of those texts, like the GT for his OCR effort, which allowed us to train here a line recognition model for these Gothic fonts and also actually the regular Latin Antiqua fonts, which is basically returning error-free results. I've included here this example of this newspaper article paragraph and the recognition results on the right. And I've been told there is actually still one recognition error in there. Maybe you can find it. I haven't found it yet. But we were able, so also in our initial evaluations, using these new deep learning OCR methods in combination with our layout analysis to reduce the amount of errors, character errors, from about 20% to even less than 2% on average, which is still not perfect, but a huge improvement, and thus really brings the quality of the text into a level where you can meaningfully do text analysis and apply semantic and natural language processing technologies. Also here, the text recognition we use, Calamari, which is actually based on a method developed at the University of Würzburg, and the model can be found on our GitHub. And yeah, with that, I think I'm already coming to the end and rounding up. So this has been the result of our first, so to say, venture or steps into applying these deep learning techniques coming mainly from industry and research to our domain, cultural heritage digitization. We found that we were able, with some adaptation and by actually supplementing those deep learning techniques with some domain knowledge and heuristics, we were really able to achieve our goals and improve the quality significantly. And we're very happy that we have also found some new avenues to explore further in a follow-up project that we are just about to start up, where we will be investigating especially some very recent advances in document layout analysis, which focus around multimodal methods. So methods that use both the optical information from the segmentation, but then also in a second channel combined with the text channel information, and combine that to get even better layout analysis and text recognition results. What I'm really looking forward to is also then to extend our work to Asian languages, Chinese, Japanese, and Korean. Since here we have to deal, for example, with, of course, very different scripts with reading order that is from right to left, and generally some very new and challenging layouts of how pages have been constructed. We will continue to work on our image extraction and classification. As I've said, that is really cherished by our users. And we will, of course, continue to release and also curate data sets that we generate for use by other researchers in AI. And complementary, we also have another project that is more focusing on the text recognition part. But also here we will introduce some new learnings from the research and from the experience we have made in the past 3 years. Like, for example, using object detection methods, which can really help improve the speed of these layout analysis techniques, and also some other avenues like integration of baselines, which will improve the quality of text line detection, and so on. And especially, and this is something I think where also much more work with the community will be needed to arrive really at good evaluation methods and metrics, specifically for document layout analysis, not just by looking at the OCR quality, but really looking especially at the segmentation and the different classes and how accurately they are detected. And hopefully also then in a community effort, we can create even more high quality ground truth data for training and evaluating document layout analysis to push the quality even further. And I think with that, I conclude, and I thank you very much for your attention and would like to open the floor for questions, please. Thank you.
Well, thank you very much, Clemens, for the nice talk. And indeed, we already have some questions from the chat. And I believe the first one is Daniel. He asks you, I think he wants to know more about the layout parsing part because their deep learning is involved. So his question is, how much manual training is required for this layout detection? Could you provide some comments there?
Yes, so actually we do some different training. We did some different training sets. So like I've mentioned, we use a combination of different deep learning models that are then triggered according to this more heuristics guided flow. And we have, I think overall, we have currently 9 models that we use. So for the text line detection, for the region classification, for the de-skewing, for the scaling, binarization, and so on. And while some of those models, so for example, ones for the quality optimization or also for binarization, we were able to train in an unsupervised way. For the text line detection and especially for the reading order, we had to manually create some new training data sets, which is quite challenging and time consuming to especially do these like very fine-grained contours for the text lines. I think overall for the segmentation models, we used data sets that were available from the DH segment project. Also some images that were available from the Impact Center of Competence, which amounts to, I think, overall something like 500 highly annotated document images with such segmentation present as ground truth. And then we also did ourselves, I think, another 200 images that we annotated specifically for the text lines. One approach that we did here that has turned out to be really useful is that we built a small tool that can shrink bounding boxes into such polygonal contours. So because there is a lot more ground truth available, which has only bounding boxes, which are not good enough to improve the quality of our model. But we can use those bounding boxes and then really shrink the bounding boxes down to these very dense contours around the characters in a kind of automatic step, and then really generate a lot more ground truth for this very fine-grained contour detection of the text lines. I hope that gave an answer to that question.
Thank you very much, Clemens. It's a very detailed well, elaboration on the process. And I'm not sure if the tool that you mentioned was Althea, because I also used the tool to derive some polygon-based contour of the text regions.
Exactly. So we use Alethea. Another tool that we also use, or that many people maybe also know, is Transcribus, where you can also do these kinds of ground truth creation. The nice thing is, so since Transcribus is now a paid service, and also the Alethea tool is, there is a free version, but only the full version, which you need to pay for, has the full feature support. So we re-implemented that particular method for shrinking the bounding boxes to polygons, also as a free software tool.
Fantastic. So the next question comes from Hank, and it's also a very specific question attending to some technical details. And the question is, during the text line detection, you still seem to have the challenge of multiple text line contours overlapping in a few spots, sometimes by just a few pixels. So how do you finally extract the individual contours of single text lines from that? So how are they getting unconnected to each other?
Thank you. Yeah, that's very, very well spotted. So I think, yeah, really quite happy and impressed with the results, especially if you remember those slides with the Arabic texts and with the handwritten text. But indeed, there can still be those overlaps. But so we found that really this adding this additional component, so to say, of this blank space between the text lines as an additional class that gets detected as part of the text line segmentation model. This really improved the text line segmentation a lot, in the sense that we were really able to tell where the descenders, so to say, of the top line have their end, and maybe ascenders of the line beneath have their limits, so to say. And but also, yeah, I think what really helped here was to, like I said before, use this polygonal and very dense polygonal text line images as ground truth for the training. And something else that I've just forgot. Oh yeah, of course, and the baselines. So this is something that we also saw, and this is an approach that I think has also been applied by others, is when you have really good baselines as well, you can sort of like extrapolate then from the baselines to the ascenders and descenders, and get like some very accurate contours.
Wow, sounds great. So basically your advice is actually solving this problem from within the deep learning framework instead of using the heuristics. So that gives a more accurate, well, segmentation of the touching text lines.
Exactly, yeah. And we use the heuristics then also to determine basically on these initial segmentation results whether we have to do the more also computationally expensive, more fine-grained analysis by cutting the image down into smaller patches, which we then sometimes also scale up. So this also helps, for example, internally then, if the text lines are very dense, This gets detected and a heuristic gets triggered that then cuts the image into patches which are scaled up so that you have more blank space between the text lines.
Wow, fantastic. Thank you very much. This is also linked to some question that I have, but I will save mine for the later part. And the next question is from Roxana. Her question is, are there any plans to extend the document layout recognition work to born digital materials like PDFs? So are there any links there as well?
That's an interesting question. It's not something that is really included in our current work or agenda. We found that there are some very good segmentation models, for example, for PDFs of scientific articles. There has been a big data set, the PubLayNet, which was released as part of ICTA in 2019. And several models, different kind of models were trained using this data set. And so, for example, Layout Parser, Detection 2, and others use this data set. And they return very good quality results for those kinds of modern documents. But we found that those models usually have really big problems when they are applied to these more historic layouts and pages. So actually we found here that we get better results by using the training or starting the training really from the historical documents rather than fine-tuning some of these other models. But if you are working or dealing with those more modern born digital documents, probably those tools would be more applicable for that than what I presented here.
Thank you very much. And the next question comes from Chef. Has much thought or effort been invested in making parts of these pipelines more widely usable among humanities and librarians and others? The OCR-D curator documentation is admirable, but it is still quite high threshold for many people. Wanting to do OCR or HTR. So
Yeah,
it's yeah.
I get the point. I think yeah, it's that's of course a challenge that we also face here. That these tools are quite technical. Also here, I must say that this is now the output of a research project. So the main aim here of the funding was to create new models, methods, and publications. But especially in the frame then of the OCR-D project, which has also been mentioned here, we try, of course, to come up with some ways that make it more accessible and usable also for non-experts. I think something that I'm really looking forward to here is in the frame of the OCR-D project, which is a bigger national effort in Germany to create OCR and related technologies for historical prints. We have a new collaboration also with the University of Würzburg, who created this Calamari text recognizer, and they are working on a project that is called OCR for All. And here the main effort is about integrating these deep learning technologies, like also the ones that I've been presenting here from Curator, in a bit more user-friendly environment with a graphical user interface, with really documentation for non-technical users. And I think this is also really important because, for example, with OCR for All, then you have a very immediate and visual return, for example, of or presentation of your segmentation result. And via the graphical user interface, people are then directly able to do corrections on these results and thereby also then produce again better material for training and evaluation. So I think it's important to also make sure that the these technologies are usable for non-experts, because then in return we can also benefit again from better quality data.
This this vision, because I think at this moment the work is more or less focused on the technical structures of the tools, but in the future maybe we have less technical intensive wrappers around those tools, which will offer the general public to be able to easily use those tools without having to referring to the technical details, because maybe some people already get turned away by just looking at a GitHub page, and instead, a graphic user tool will be much easier for the general public to use. But indeed, some really interesting thoughts. And I have to move to the next question, which I believe is from Sven. And the question concerning actually concerns again about specialized models and generalized models. So the question is, suppose that you have different types of documents with different characteristics, newspapers against magazine pages, and so on and so forth. In your experience, would a general model work better than several specialized models?
Yeah, that's a really interesting question that we've also been pondering around with quite a bit. As you saw, what I've presented today, it's while still using a combination of different individual models, our aim here is really to have one general or generic tool that can really provide a good performance for a large class of documents, even such diverse documents as newspapers and, say, handwritten manuscripts. And we hope that by including also these new multimodal approaches to even improve the performance more. But we also see, of course, that we are hitting some boundaries there. For some cases, it will definitely make sense to train then specific models or to fine-tune a generic model for those particular cases. And it's something that I think we will have to do also in the future a bit more to specialize some models for particular types of documents.
Thank you very much. And let's move to the next question from Annemieke. So the question is about more accurate recognition of the layout. So the question is, do you have Algorand choose models for the layout that classify or identify elements such as title, page number, marginals per page, but more importantly, recognize the structure of larger entities like chapters and forward and so on and so forth? And the question is being asked because the idea is the OCR quality or HTR performance can be improved by knowing whether something is positioned at a place where you may suspect. For example, if you say young, then you think that this refers to a name, but not to, for example, a month. So do you have some experiences there or advice there as well?
That is actually something which is more or less like written down the work plan of what we want to do next with what I called these multimodal approaches. So indeed, we have some knowledge about, say, what kind of texts can appear at a certain space, for example, just from domain knowledge. And then that part gets really interesting, like also explained here, once you combine also then text recognition with it, because you can then really provide more rules and heuristics about what type of content can be rightfully expected at a certain within a certain region or within a certain area of the page, for example, so that you could indeed say if Jen appears like in a certain segment that is then on the top left, say, for example, on a newspaper, it's quite obvious, or you can build a rule to determine that it will be referring to the date of the month rather than to the name. And so this is really what we like to extend the work on then in the coming years.
Fantastic. And the next comment is from Matthias. So, well, it was great to see the processing of CGK material on the next steps list. Can you elaborate on the material and periods you plan to focus on? And perhaps you're also considering some collaborations in this regard?
Yeah, thank you, Matthias. Of course, we're always interested in collaborations. I have to say, I'm not really fully aware of how we're gonna do it. We have to experiment a bit. And we will focus mainly on Chinese here. And the collections that we have in our library in the Cross Asia department, which Matthias knows quite well, the colleagues there. So which is a large kind of like special subject collection of East Asian materials with a focus on mainly Chinese. And the first thing I think here also that we're starting on is Chinese newspapers. And yeah, obviously we would be always interested in collaborations or finding out what others have maybe already done in this area, or where also maybe suitable data or tools are available that we could adopt and reuse.
Well, sounds really great. And also it's very interesting for me as well. And we have
great. Some people already found some of the tools. OCR for all, yes.
Yes, indeed. We have a returning comment from Chef. And so just looked it up from the OCR for All website and looks brilliant. And his field is design, and he's looking specifically at HTR at scale, therefore strong interest in broad range usage there. So maybe there are some potential links as well.
Yeah, definitely. And so OCR for all. So one of the things that we're doing now, we entered a collaboration with them, like I've mentioned, in the OCRD project. And the idea is that over the next 2 years, basically all of the algorithms and methods that are currently available via OCRD or Curator in the form of like command line tools or through APIs, they should all be integrated into the OCR for all graphical user interface, so that you can then also use them from that interface subsequently.
Great. And I think we have covered more or less the questions from the chat.
Yeah, and I will be happy to upload the slides, or the organizers will share them. Otherwise, I will be happy to share them. Yeah.
Yes. So I would like to also invite the audience who still have questions or comments. Just you can just raise your hand and turn on your microphone to directly interact with Clemens if you still have questions or comments. Well, maybe while we're waiting for some other questions, I will take this chance and ask a few questions of myself. The first question I have is regarding the balance between heuristics and modeling, for example, using deep learning, because I think that's two of the main strategies that have been applied when it comes to document analysis and layout parsing and so on and so forth. And there seems to be a fighting between deep learning oriented approaches versus heuristic approach, which is why it is very interesting for me and also inspiring for me to see that, Clemens, in your work, you actually have a constructive combination of both. So you have your deep learning models, but also you enhance the performance with heuristics. Moving forward, how do you see this combination? How do you see the role of heuristic-based approaches and the deep learning-based approach? Do you think the deep learning-based approach will eventually be the main value that everybody will be focused in?
Thank you. Yeah, that's a really interesting question, and I think we've seen a lot of examples in research and in industrial applications where really pure deep learning systems were able to achieve like really tremendous quality. Actually, at that time when you have to deal with like really varied collections of documents, I think heuristics can then really help like to determine from some, like we do initial feature extraction or classification, like what kind of model, and in this case again it's then maybe a bit of an example of a multi-model and fine-tuned model approach, where then you use the heuristics to determine which model actually is the correct one to use in this particular case. And I think there is still a lot of room for improvement, which maybe is also interesting because it reduces both the effort for creation of training data and also the computational effort in rule-based approaches. And documents are well, created by humans according to rules that have been established over many centuries, and there's still a lot of domain knowledge, I think, that we can leverage to build into these rule sets to improve the quality and performance of the layout analysis in those ways. And yeah, that, like I said, those sometimes come at a bit of a cheaper price, both computationally and training-wise. And still provide tremendous boost to the performance. So what I would like to see, and this is also something I think we try to do in the future, to also make these rule sets more independent of the models, so that potentially you could even say you can apply these kinds of rules over the results of different deep learning frameworks for document analysis in a sort of like, again, a generic way to boost their performance. So I think, in my view, it will always be a bit of a combination here, which will be a good trade-off. And ideally, you want to, of course, have both so generic that you can recombine and reuse them in a way that is really tailor-fit to your particular collection of documents.
Thank you very much. And yeah, I do actually have a second question. So it's actually related to my experience, because I think just over the last few years, I have seen an increasing number of advertisements pertaining to AI-based document processing and so on and so forth. And we all know that there are well-established tools such as Abby Fine Reader, Tesseract, which is currently under the umbrella of Google, but also something more recent like Google Vision and so on and so forth. So based on your expertise and experience, what do you think are still missing in those tools? And what are, do you think, opportunities for the researchers to continue to work in the field of document processing?
Yeah, thank you. That's it's funny, since it's especially those tools that you mentioned. So we've been working in the past a lot with, say, Abby Fine Reader, which also I think now it's started out as a traditional, say, omnifont classifier and also pixel-wise segmentation. I think there is now some machine learning also in it, but it's always a bit hard to say with these like commercial products. We found that with Tesseract, which by the way now is also maintained by the community a lot, there's still a very good momentum of improvements with the text classification, but I think the initial document layout layout analysis part of Tesseract is still more or less based around the Leptonica library and what Ray Smith did years ago, even before the big deep learning hype started. So we found that we're still using Tesseract a lot as a line recognizer. Sometimes, for example, for the not German broken fonts, it has a better text recognition than, for example, Calamari. But the standard layout analysis that ships with it, it's really not up to standards, especially for multi-column documents anymore. So this is also why we basically started developing this tool, because we needed some layout analysis method specifically for these historical documents and specifically for the multi-column documents. And I think, yeah, there is still a lot of possibilities to do meaningful work in this area by expanding those methods to, for example, include new classes that are being detected, to do more fine-grained analysis of the individual classes, and generally just still boost the performance for those very tricky historical documents, especially I think also looking at what the HDR community is doing. There's some interesting possibilities also there, and for collaboration. Something that I've often been asked is when we have these handwritten annotations within printed documents, could we not, for example, detect those also then, and then basically apply a standard OCR for the printed part and an HDR for the handwritten, and keep those kind of interrelated. So I think, yeah, there's still a lot of things that are worthwhile doing and investing in as a researcher. And yeah, hundreds and millions of documents in libraries that are still waiting to be discovered, that will also certainly reveal some new challenges as well.
Thank you very much, Clemens. And I think we have already drained you too much with all these questions. But perhaps we have one last question from Matthias. So the question is also somehow you answered this question already, but the question is asking, currently most OCR or HTR pipelines still focus on the actual text or articles. Do you foresee that advertisement will become processable in the future, or do we have to wait another 10 or so years for that kind of complexity? So do you think our models are strong enough to process really complex layouts, or what is your advice here?
Yeah, that's a nice question to end with, maybe, because here I can really refer to the work of some good colleagues, where I also really have a lot of recognition of their work. So Melvin Wevers and Thomas Smits from the Netherlands, they did something a couple of years ago called Siamese, which is a Siamese model, also neural network model, that was used specifically for the classification and the detection and classification of adverts in historical newspapers of the National Library of the Netherlands. And I think, yeah, so there are some examples already that have been doing this successful. And fortunately, we don't have to wait the 10 years. I still think this is probably one of those cases, again, where you need models that are specifically tailored to that challenge, because as fun and as interesting these historical, especially efforts are, as creative and as challenging is the way that they have been set and printed. So I think, yeah, here you need like a specialized approach. But yeah, like somebody put it already in the chat, others have already done that, fortunately.
Thank you very much, Clemens, and thank you, Sally, for the link. And yes, well, I just want to say one more time that really thank you very much, Clemens, for this really, really nice talk and for all the detailed elaboration and explanation on the process and your vision and advice. And I would also like to thank all the participants for joining us on this occasion and for interacting in such a constructive way. And also big thanks to all my co-organizers for bringing up this event. And I do hope that in the near future we'll come together again for such nice workshops or talks. So thank you very much.